Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll consider trigonometric concepts related to sine and cosine law. We are going to take application questions which will be based on ambiguous triangles, navigation, and application of cosine law and sine law to find area. I hope you find them interesting and useful. You can master the strategies and succeed, and also develop critical thinking skills by joining my classes. Stay ahead of the competition just as Abhinav is. Let us enjoy this session with Abhinav. Hi Abhinav, how are you doing?
I'm good. How are you?
Very good, very good. So today, what do you want to learn, Abhinav?
About cosine law and the ambiguous case.
Okay. So ambiguous cases we discussed in sine law. We'll start from there and then take up cosine law and some examples today. Is it okay?
Okay.
Let me share with you my lesson on this. Uh, so can you please read what is given on the top?
Solve triangles. Triangle ABC. Angle A equals 60 degrees. Side A equals 30 centimeters and side B equals 20 centimeters. Round angles to the nearest degree and side length to the tenth of the units.
Okay. So the diagram is shown for you. We are given angle A at 60 degrees. Side opposite to A, which is lowercase a, is 30 centimeters. And then 20 centimeters is the side B, which is as shown in the particular diagram. Correct? You need to solve this triangle. Solving really means you have to find the unknown side AB and the angle B, right? So
Yeah.
tell me, how will you solve this?
So you can use the law of sine. So you can do 30 over
Yeah,
sine 60
correct,
equals 20 over sine B.
correct.
And then 30 sine B equals 20 sine 60. And
Yes,
B equals 20 sine 60 over 30 sine B.
correct.
I mean,
Oh,
20 sine 60 over sine 30.
correct. So now you can find the angle B from here, right?
Yeah.
Correct. So when you calculate angle B, the calculations are done for you. You can also do them. So sine B is 20 over 30 times sine 60, and you get an answer which is 0.5773. And when you do inverse of this, you get the angle B as 35 degrees, correct?
Yeah.
Is that the only solution, or could you have two solutions?
That's the only solution.
Correct. Because the side A is longer than side B, right?
Yeah.
So we have an acute angle. And since we know that A is greater than B, which is very clearly written here, so it is a side angle where A is greater than B. In that case, we have only one solution. Perfect. And that's the solution. So you get this. Now you can find angle C as 180 minus sum of the other two angles, and then again apply the sine law to find A to B, correct?
Yeah.
So get AB over sine 85, which is we found just now as difference of 180 and 60 plus 35. And from there we get 34.5 centimeters as the length of AB. Can you please read example 8b?
Okay. Solve triangles. Triangle ABC. Angle A equals 50 degrees. Side A equals 25 centimeters. And side B equals 30 centimeters.
Right.
Round angles to nearest degree and side length to tenth of the units.
So when you are given this question, what will you do first?
So you have to solve for the angles. So you have to find side BC first.
BC is given to you, AC is given to you. Now in this case, it is acute angle, and you see that side A is actually less than side B, right? This is 25 and that is 30, correct?
Yeah.
Since it is less than, we could have ambiguous cases, correct? So you have to check, is it equal to perpendicular? Is it longer than perpendicular or shorter than perpendicular? If this side is shorter than perpendicular, you cannot form a triangle. And if it is longer than the perpendicular, two triangles can be formed. And if it is equal to the perpendicular, only one triangle will be formed, and that will be right angle triangle, correct?
Yeah.
And therefore, first thing which we do is we see that A is less than B, and perpendicular here will be B sine A, right? Opposite to sine A, opposite to A, sine A relation. So B sine A. So B sine A is 30 times sine of 50, which is 23.0, correct? So we see
Yeah.
that angle A is less than B, but it is greater than the B sine A, right?
Yeah.
Therefore, we get two triangles. Is it okay?
Yeah.
So as shown here, another triangle can be formed on the other side, and we could have B dash point. So we have two triangles to solve. Is that clear?
Yeah.
So first, we'll solve the bigger triangle and find the angle B using sine law, just as we did in the last example, correct?
Yeah.
So this time, can you tell me what is this angle B? So when you want to find angle B, using sine law, I will keep that on the top. So I'll say sine B over side opposite 30 equals to, and the combination given to us, sine 50 over side opposite 25. And from here we can find sine B, cross multiply, and then inverse will give you the angle, correct?
Yeah.
Can you do the calculations? Tell me the answer.
Yeah. Okay.
66.8 was correct. So I can round this to 67 degrees. Is it okay?
Yeah.
Round the angles to nearest degree. So I'm rounding to 67 degrees. Yeah, you got correct. Sorry. 67 degrees. And therefore, you can now find C also, right?
Yeah.
So C will be 180 minus 67 minus 50, and that gives you 63 degrees.
Okay.
And now you can find AB, correct?
Yeah.
Fine. So write AB on top. AB over sine. But when you find side C, don't round and do. Get the right answer, right? 66.81 this was. So use 66.81 in your calculation so that your answer is more accurate. Then you round your answer.
Okay. So angle C is 63, right?
Angle C will be use 66.81 in your calculation. 180 minus 66.81. We'll round later.
Okay.
Yeah, let's do it like this.
So it's 63.19.
Yeah. So use 63.19, 63.19 or 18. So that will give you more accurate result, 25 over sine of 50. And now find AB.
29.12.
49.12. Now round it to,
I got 29.
oh, sorry, 29. Okay, yeah. Okay, 29.12. Okay.
Yeah.
Yeah. Okay. So, yeah, this is smaller than that. That's the correct answer. 29.12, round to one decimal place, 29.1. So, sides to 10th unit. So, you get 29.1 as your AB. Now, this is a big triangle. Since you know it's an ambiguous case, can you tell me what is the other angle at B dash? 1
Angle.
minus B, right? So, the other angle will be 180 minus 66.81. Because this is an isosceles triangle, right? So the exterior angle will be 180 minus 66.8. So that is the other triangle. So we are now solving for the second triangle.
Okay.
As shown in this figure, right? So here we have rounded and we are getting the rounded answers. You see this?
Yeah.
We are solving the second triangle. We know the side B dash C is 25 as given to us. And again, you apply the sine law to find the angles. So first the angle at C now is 180 minus 50 minus 113, which is 17 degrees. And now apply the sine law and get your answer.
Okay. How do you know if a triangle is like ambiguous? How do you know if it's an ambiguous case?
Okay. Let me take a whiteboard to explain you this concept. Is it okay?
Yeah.
So you remember the dimensions? Just I'll ask you, and then we'll again work out this case. Let me stop sharing this and we'll go to a whiteboard so that I get space to work with. That's the whole idea. So once again, Can you tell me what the question was? What was given to us?
I think the side lines were 29, one was 30, and I think the other one was 31.
No, we were given angle A, which was 50 degrees. Correct? This was
Yeah,
30. This was 25, right?
yeah,
That was given to us. Now, first thing we worked out is we are saying this is A, and that is B, and this is C. So we say what will be the perpendicular distance? The shortest distance will be how much? C to D, let us say, right? So I'm just telling you the concept, right? So CD will be basically CD over AC is sine A, right?
yeah,
So CD is equals to AC sine A, which is 30 sine 50, correct?
yeah,
We got this value of CD. They are perpendicular. We figured out this was approximately equal to 23, right? And
yeah,
since this side 25 is greater than 23 and is less than 30, right? So this is like say approximately 23, right? And this side is 25. So I could have a triangle like this. Do you see that? I could also make a triangle like this, correct?
yeah,
Where this is also 25. So I get the second triangle. So basically, I'm looking at two triangles here. One is this, and the other one is this. Do you see that?
yeah,
So that's the case. You get the idea, right?
yeah,
Because these sides are equal. These are opposite to A. So these sides are A each. Now this angle, let us say this angle is theta. Then because it's an isosceles triangle, this will be theta, right? And what will
yeah,
be that angle? 180 minus theta. You get the idea.
yeah,
And therefore, in our example, we worked out that angle B was something like 66.8, right?
yeah,
Let's say we got this as 67 degrees. In that case, the other angle will be 180 minus 67, right?
yeah,
So we get this as 180 minus 67, and that will give us that angle as 50 is here, right? So
yeah,
67 is an external angle equal to 50 plus 17, right? You see 17 degrees at C? Because this is exterior angle 67, right?
yeah,
So exterior angle is sum of two interior angles. You can use this triangle law. Otherwise, you can do 180 minus this and this.
yeah,
So you get that 70. Now, this is our second triangle. You see that triangle?
yeah,
So we'll solve the second triangle also. So we have two solutions. Ambiguous because we have two triangles. One is triangle, the bigger one, ABC, and the other one is the triangle AB dash C, where this is B dash. You get the idea now.
yeah.
We'll again apply the sine law just as we did for the bigger triangle and solve for this.
Okay.
Understood?
Yeah.
So that's how we are going to do it. Now we'll get back to our uh, lesson. Correct. So here, as I was saying, we just worked this out again for the smaller triangle, right? Which is shown here. And we find that for smaller triangle, this side is 9.5. We know that angle is 17, and we have our result. Perfect?
Yeah.
Right. So this is an ambiguous case. Now, here's another example. Can you please read the example?
Okay. Solve triangles. Solve triangle ABC. Angle A equals 40 degrees. Side A equals 10 centimeters. And side B equals 25 centimeters. Round the angles to the nearest degree and side length to the tenth of the units.
So in this case, again, we have an angle, which is an acute angle. And side A is less than side B. We have to see as compared to the leg of an hypotenuse triangle. Is it long enough to form a triangle? And we see that that side is what? This perpendicular could be 25 sine of 40, correct?
Yeah.
And 25 sine We calculate it was around
Yeah.
23, right? Since 10 is less than 23, it will like hang. You see that it cannot touch this line, correct?
Yeah.
So a closed triangle cannot be formed. And
So if
therefore,
a perpendicular line, if it's less than the angle to the right of it, then the triangle can't be formed.
yeah.
Okay.
So this length, which I'm saying is this length should be longer, right, to make it full triangle?
Yeah.
Or exactly when it is length of the perpendicular. If it is longer, it can form two triangles. Do you see that? That's the whole idea.
Yeah.
In this particular case, we see that this is shorter, so it cannot form a triangle, correct?
Yeah.
So A is 10, which is less than 16. Well, I calculated, 40 degrees was 16, not 23. Less than 16, therefore triangle cannot be formed. Is that clear to you?
Yeah.
Now, next example is where the side is exactly equal to the perpendicular. You can now read the question.
Okay. Solve triangle ABC. Angle A equals 64.2 degrees, side A equals 27 centimeters, and side B equals 30 centimeters. Round angles to the nearest degree and side length to the tenth of the units.
So we have angle A, 64, side opposite, 27, and B is this. So first, because A is less than 30, first condition is met. We'll check what is B sine A, right? So calculate B sine A.
Okay.
Calculate B sine A, what do you get? Means 30 sine of 64.2 is how much?
Okay. I got 27.009.
Which is same as 27 given to us, right?
Yeah.
That means it forms a right angle triangle, correct? You got the job, right?
Yeah.
So it is the opposite side, and there was a right angle triangle. This is 90. Find the difference between 90 and 64.2. Get the other angle. Done. So you saw with these four examples, we had exact right angle formed. The side was so given. The triangle could not be formed. And there was a case when we could make two triangles. And if A is longer than B, in that case, only one triangle will be formed. So we had these four cases. Are these absolutely clear to you?
Yeah.
Right. So that's how we'll do it, right? So let's move on. And here we have an application question. Can you please read this question?
Okay. Coast Guard Station A is located 400 meters due west of Station B. A ship at sea sends SOS call that is received. The call to Station A indicates bearing of the ship at north 35 degrees east. The call to Station B indicates that the bearing or ship from Station B is north 56 degrees west. Figure illustrates the situation. A. How far is the ship from each station? B. How much time will a helicopter flying at 340 kilometers per hour take to reach the ship from Station A?
Right. So we have a rescue ship at this particular point as shown. So you need to understand this angle, right? You see, the call to station A indicates bearing of a ship as north 35 degrees east. So north 35 degrees east means this is your north, right?
Yeah.
So if you take a reference frame from here, 35 degrees east. So that is what is shown here. So we have north 35 degrees east. Do you see that?
Yeah.
Similarly, the other angle from a point B, which is on the east, 46 degrees west. You see that? So those angles give you the base angle
Okay.
of the triangle form. With the two angles, you can always find the opposite angle. So we know all the three angles, correct? We also know the distance A to B, which is 400 meters, since A is 400 meters west of B, correct?
Yeah.
Now, we need to find the sides, correct? We can always find these sides using sine law, correct?
Yeah.
Because we have one combination, which is this angle and side, and then apply the sine law and get your answer. Is that clear to you?
Yeah.
So that is all. This is a very beautiful application question and very easily solved, but making a diagram could be tricky. So you first understand how do we make this diagram? Is this clear to you, diagram itself?
Yeah.
Perfect. And then A over sine of 44 will give you 400 over sine of 81. So you get find A, and then similar. You can find B as B over sine 55 is equals to 400 over sine 81, right? And you get your answers, correct?
Yeah.
And the other part is how much time will a flying helicopter take? You know the speed, distance, and time relationship, right? So you can make a triangle, which you know is distance is speed and time. That is how, and time taken will be equals to distance divided by speed, right? So once you divide, you know the time taken by the helicopter. Is it okay? Kilometers per hour. Perfect.
Yeah.
Now with that, I'll take the last example just to show you the solution of an ambiguous case. You should practice this type of questions on your own, correct?
Yeah.
So law of cosines, law of sine we're still working on. Whenever you're given one angle and two sides, you should check for ambiguous cases. That is very important, especially if the angle is an acute angle. See if the opposite side is greater than, less than, or less than the given other side, right? So we have to see the ratio. If in a triangle, let me say this triangle is A, B, and C, side opposite will be A. So you have to check A. It should be less than B. And if it is greater than B sine A, in that case, we have two cases. So two cases, solve the bigger one, then you know this is an isosceles triangle. These two are equal, and therefore you can find all these angles, correct?
Yeah.
So this diagram clearly shows the solution to the given question, and also the two triangles formed. So B2 is the other point B, which gives you a smaller triangle. So solve both the cases if you have that kind of a situation. Clear?
Yeah.
Okay, so now let's get into cosine law. So what we learned, I'm not getting into the derivation of cosine law, but I'm leaving this page for the viewers to see so that they can understand the derivation. Is it okay?
Yeah.
But normally, we don't really get into the derivation. We will not get in this part of the video. So if I'm given a triangle, let us say, and let me label this triangle as ABC, where the sides are lowercase ABC, that is a nomenclature. In that case, the sine law says that the cosine law. Now, if we relate, if we know all the sides, let us say we have all sides known to us, right? We know these three sides. Can you apply sine law?
No, because you don't have the angles.
We don't have the angle opposite to any side, so we cannot do it. And therefore, we have to now look for a new formula. So as you have seen here, using Pythagorean theorem, we can actually solve these two triangles, all the calculations shown. Once you do that, you come to a formula that one side whose out of these three sides, any side can be related with the formula. For example, C is the side of concern, then C will be A square plus B square minus 2AB cos of C. So that is the formula, which is called cosine law. Is that okay?
Yeah.
Right. So derivation is given to you. So you can always pause the video and look into the derivation, but we'll see how do we apply the formula. So the formula is, in any such triangle, let me again make one more triangle here to discuss the formula. Easy to remember. Let's say this is ABC. And now let us say we have this combination. Two sides and an angle. Even then you can apply the cosine law. Anyway, this formula is, this is A, this is B, and this is C. A square, side opposite to this angle, A square is equal to sum of these two squares minus 2 times these two sides times cos of A. That is the
Yeah.
formula. You get the idea? Easy to remember?
Yeah.
You could always rearrange this formula to find other sides, but you could also rearrange to find the angle. So, bringing 2bc cos A to the left side, this is minus 2bc cos A, right? I bring it to the left side, I get, see here I've done, right? Bringing to the left side, I get 2bc cos A, and bringing A square on the other side, B square plus C square minus A square, correct?
Yeah.
We are trying to isolate or make cos A as a subject. So cos A is B square plus C square minus A square divided by 2bc. And so we can find the cosine That means we can find the angle A also, right?
Yeah.
In this formula, you can clearly see we can find all the angles just by knowing the sides. So sum of squares of two sides take away difference of the third side square divided by 2 over product of adjacent sides. So whenever we relate angle, we relate this corner. Is it okay for
Yeah.
cosine? And that minus thing is the other thing. So that becomes your cosine law formula. And based on this, here is another question for you. Example 12. Can you please read the question?
Okay. Find the side length using cosine law and side angle side case.
Right.
Solve triangle ABC. A equals 58 degrees, B equals 5.2, and C equals 4.1.
Sorry. So in this, you do not have this combination of opposite sides. So you cannot apply sine law, right?
Yeah.
So there are two cases. One is when we are given two sides and an angle, and the other is we are given the three sides when you have to use cosine law. Clear? Write down.
Okay. Yeah, I wrote it down.
Now we can apply the formula. We need to find A. So add squares of these two, B squared plus C squared minus 2BC cos A. We know the angle in between. And calculate. So once you do that, you get 4.6 as the length A.
Okay.
Now, once you know this side, which is 4.6 for us, you can find the other angle using sine law, correct? That is
Yeah.
easy. So apply sine law, get the other angle. Subtract, get the third angle, your triangle is solved. So most of the time, whenever cosine law is involved, we try to solve for one of the parameters using cosine law. It could be angle or a side. And then we use the sine law to finish it off. Is it okay?
Yeah.
Here's another example. Can you please read this particular question?
A triangular yard, 7 meters by 8 meters by 9 meters, is to be covered with sod. Find the cost if sod cost $1.75 per meter squared.
Very good question, seen in many examinations. So basically, we need to find area of the triangle and multiply with the cost to get the total cost, right? How do you find the area of triangle? We need to find the height and the base, right?
Yeah.
So in this particular situation, 7, 8, 9, so that means we know the base. We need to find the height. To find the height, I have to find the angle, right?
Yeah.
And it will be 7 sine of angle A is the height, right? So we know height is equals to 7 sine A, right?
Yeah.
Or we have to find angle A. How do you find angle A? Use cosine law. So we
Yeah.
have used cosine law. Cos of A is this square plus this square, these two squares, adjacent sides. Take away 9. You see that?
Yeah.
So 7 square plus 8 square, take away 9 square. This should be minus here. And then you divide by 2 times BC as given in the formula, and then find cos inverse to get the answer. Is that clear?
Yeah.
In this case, you get 73.4 as the angle A. Once you have this particular angle, then you find h sine A. So you know the height, correct?
Yeah.
And then you apply the formula. Area of the triangle is half base into height. Get the answer, correct?
Yeah.
Now, this is one way of doing area of triangle. At this time, I'd like you to also understand the Heron's formula for finding area of triangle. So make a note of this particular formula. I'll explain you and make a note of this.
Okay.
Many times we could directly find using the sides.
Yeah. Got it.
Here, S is called semi-half, that means, right? Semi-perimeter. So you're given any triangle, let us say given three sides. Let's call these sides as A, B, and C. In that case, semi-perimeter as shown here is half of A plus B plus C, right? You see
Yeah.
it? So in this case, 7, 8, 9 was given to us as a size. We add them, divide by 2, and we get a value 12. Heron's formula is S. Heron's formula is semi-perimeter S times S minus A, S minus B, S minus C. So you have this product within the square root to find area straight away from the given size. You don't have to find the angle.
Okay.
So both answers are similar. 12 square root 5. You know the rate. Multiply by the rate to find the cost of sort to be put on this triangular field. Is that okay now?
Yeah.
So that is how a very beautiful question based on area of triangle can be solved. Is this concept clear to you?
Yeah.
Perfect. Now, here's a practice question for you. Why don't you copy this and then solve?
Right. It solve for angle A, right?
Yes, you can use cosine law to solve for angle A, right? But the answer is to find sine A. So that's the tricky part.
Okay. Sine A is equal to 0.57.
Okay. So let's read the question. Can you please read the question?
Three sides of of triangle ABC are AB equals 6, BC equals 7, and AC equals 11.
Right.
Find the exact value of sine A.
So you have to find exact value of sine A, right? So what is our approach? We are finding what is cos A first, right? So we find what is cos A. And cos A is square of these two, which is 6 square plus 11 square minus 7 square, right?
Yeah.
So that gives us a value 9 over 11. So do not write decimals, write 9 over 11. Now,
Okay.
make a right angle triangle. So this is my angle A. So 9 over 11 means this,
Yeah.
right? So what is going to be the other side? The other side will be 11 square minus 9 square square root 10.
Yeah.
So when you do that, you get 2 square root 10. You see that calculation?
Yeah.
And therefore, sine will be what? Opposite over hypotenuse. This is 2 square root 10. And therefore, the answer will be 2 square root 10 over 11. You see how we found the exact value of sine A?
Yeah.
Very tricky question and difficult question to begin with. We have just learned cosine law today, and you see how difficult questions we have solved. Perfect. So
Yeah.
I'm just sharing the other page to let you know this is next question. So once I upload this video, in that case, you can actually pause and then do these questions on your own, correct?
Okay.
Similar kind. So that is how you have to do. So let this be the last question, right? So that is how we have to do it. So now, using sine law and cosine law, we actually did a lot of examples. You remember this type of question? Badger and honey sucker bird, right?
Yeah.
So we had this example here where we derived the general formula. So here we have some questions for you which are based on our learnings, right? Answers are given so that you can practice and solve these questions. Clear?
Yeah.
Actually, this question is very interesting, and it is good idea to derive the formula also, which we derived in our earlier lessons, that you can find this height in terms of angles measured at 2 points from where we are checking the angle of elevation, right?
Okay.
So you can have this derivation, and then based on this, now here is another promotion. You can read the question, please.
Okay.
Example 80.
A promotional blimp was observed from two stations, A and B, located 0.4 kilometers apart on Highway North. The bearing of the stationary blimp from A is 037.4 degrees, and its angle of elevation is 48.5 degrees, while from B, its bearing is 032.6 degrees. Calculate the height of the balloon.
So in this, we are introducing you bearing angle. That is one thing. Second, 3D, right? So we are now talking about elevation and systems in 3D, applying sine law and cosine law. Slightly calculate. This is difficult case. We'll consider in the next class. Is that okay?
Yeah.
So bearing angles and 3D applications is what we'll discuss in the next class. So we're ending
Okay.
our session now. Can you revise? Can you summarize your learnings for today's class?
Yeah. So we learned about the ambiguous cases of triangles and how to recognize ambiguous cases and how many different triangles can be formed. And then we learned about cosine law and how it can be applied to word problems. And it only works on side, side, side or side, side angle.
Correct.
Yeah. And
Very,
we did different word problems with them.
very good. So let me actually, to end the class,
Okay.
let us summarize what we learned.
Okay.
First, sorry, we learned sine law, which was sine A over A equals to sine B over B equals to sine C over sine C over C, right?
Yeah.
We are always talking about a triangle, which is, we say, written as ABC, any general triangle, where sides opposite to the triangle will be written in lowercase. Now, in this particular case, if angle A is acute, in that case, what we try to figure out is how is the side A related with the altitude? Is that okay? Altitude. As you know, this altitude basically is B sine A. So, if angle A is less than B but greater than B sine A, then we have two triangles. But if angle A is less than B but it is equal to B sine A, then we have right triangle, right?
Yeah.
But otherwise, no triangle. If angle A is actually less than B and also angle A, A is less than also B sine A, correct?
Yeah.
In that case, no triangle. Also, we learn that Sine law can be applied if you have these conditions. That is, we know one combination of opposite side with the angle. Then you could know the other side, or if we have this combination, in that case, you could also have another angle. So in these two cases, we can apply the sine law. However, if you have the case when we talk about only three sides known to us, or if we talk about knowing this angle and two sides, then we use cosine. Right? So cosine law formula is that a square equals to b square plus c square minus 2bc cos a. This formula can be rearranged. So we have 2bc cos a equals to a square, b square I should write first. B square plus c square minus a square, or we can say cos a equals to b square plus c square minus a square divided by 2bc, correct?
Yeah.
So that becomes the cosine. So we can apply the cosine. So, and you also saw normally you have to apply the cosine law followed by sine law to finish up the question, right?
Yeah.
So that is the summary. In the next class, we will talk about two things mainly. One is 3D applications, and these applications may involve bearing angle.
Okay.
So we'll understand what is a bearing angle, and navigational problems will be solved using sine and cosine. That'll be very interesting. Is that clear to you?
Yes.
Okay, great. We'll end the session here for now, and see you in the next class. Okay?
Okay.
Okay then. Bye. Thank you.